Welcome back as we go into the last 10 days of the 30 days Lost in Space adventure. This video is going to be concentrating on the OLED display that comes with the kit. This is a little 128 by 64 color display. We're going to be utilizing this along with a few other components, and it should be an interesting few days of experiments. So let's get straight into it. Here's the circuit, very simple. The OLED display basically has 4 wires, 5 volts and ground, and it has a clock pin and a data pin, which are green and yellow. The display itself is one of many types of sensors on these Arduino/Hero boards that use the I2C communications bus. This is basically a serial-based single-pin data transmission system driven by a clock. And you'll find there's many peripherals and sensors that use this I2C. It's extremely simple to use and allows you to get away with just a couple of wires. For day 21, we're going to be doing just a very simple display on the screen to get it to work. So let's dive straight into the code. The first thing we need to do is to download the library that's going to control the display. So just as we've done in the past, we go up to Tools, Manage Libraries, and in the Library Manager, we're looking for U8G. And this is the library we want, the U8G lib. We'll select the latest version and we'll install that library. Now in the code at the very top, you can see we're doing the usual include of the library header file, which will bring in all the details, allowing us to communicate with the display. And we're setting up the actual display itself, which in this case is an SH1106 display, apparently, 128 by 64 pixels. Our draw function is going to get called on a regular interval, and that's what actually renders anything to the display. We're going to use a default font, and we're going to print 3 strings. This is the X coordinate and the Y coordinate in pixels on the display. So we're going to display 3 lines. In the setup, we're basically setting a color index, which just basically means we're going to be using a color, otherwise we're not going to see anything. It's going to be black. And then in the loop, it's very simple. All we're going to do is call this draw function in a do while loop. Now, this panel uses this first page, next page principle, which we won't go into right now. We'll come to it later. But it basically uses this mechanism to determine when we're done. And here's the output on the display. Just as we said in the program, it's displaying 3 lines. Build everything in vent safe. Ignore the flicker. That's just an artifact of the camera shutter speed and the display refresh period. So that's it. Extremely simple program today. Let's move on to the next day, day 22. Today we're going to be using the exact same circuit from before, simply the display panel connected up to the Hero board via I2C. And we've got a more sophisticated program that's going to demonstrate some of the graphics capability of the display panel. So let's take a look through the code. Just as before, at the top we have the instantiation of the panel and the library. And we're going to walk through a series of graphic demonstrations. The loop is very similar to before in that we're going to be calling the draw routine, except this time we're going to be incrementing something called the draw state. And that's going to be used if we look at the draw function itself. So we're basically running through 8 different graphics cases: a box frame, disk and a circle, a frame, a string, lines, triangles, a couple of ASCII screens, and then a scaling demonstration, a text scaling demonstration. The draw state is ostensibly going to be counting up 0 to 8, but within it we're going to have 7 different steps. So basically it's going to count 0 to 7. On 8 it's going to switch to the next case, count up another 7, and then switch to the next case, and so on. So in fact each of these cases in this switch statement represent a step of 8. And that's why in the switch itself we're logically shifting the draw state rate by 3, which essentially is going to turn an 8 into a 1. And that's going to allow us to count up to 7 in each of these demonstrations. So the first thing it does in the draw routine is it runs this prepare function, which is simply just some housekeeping to set up some parameters of the display. We're going to set a font size and a foreground color and so on. And in fact, at the top of the code, there's a link to a wiki page that will give you full details on every single one of the panel functions that we're going to use. It's very, very powerful. So let's take a look at each of these 9 demonstrations. Box frame is basically going to draw a solid and a framed box. Circle is going to demonstrate a filled and an outlined circle. Frame is going to draw an outline and a solid frame, and we're going to round the corners off. String is going to demonstrate text rotated by 90, 180, or 270 degrees. Line is going to demonstrate a series of vector lines. Triangle is going to give a demonstration of filled triangles. ASCII 1 and ASCII 2 are going to demonstrate 2 pages of the ASCII table. There's a lot of code in this extra page that basically detects the type of panel. If it's a color high-res panel, it will demonstrate a color page. If it's a grayscale display, then it will produce some graphics using shades of gray, but otherwise it will simply display the scaled text, which is what mine does when I run it. So I get none of the grayscales nor the color. So I don't know if that means this kit sometimes ships with a color display, but it looks like mine is a monochrome. Let's take a look at it running. The program's pretty complicated, so you might want to take some time to look through the program and to look at the wiki documentation so you can see exactly what all the parameters are to these functions. It's going to be fun to be able to build some very cool programs using these capabilities. Let's move on to the next day, in which I think we're going to combine this panel with some other components. So today, we start building the foundation for our launch control computer that's going to help us get our spaceship off this planet once and for all. This is going to utilize both displays, the OLED display, which we were working with in the last couple of days, and the 4-digit 7-segment display that we were using in previous days. So as usual, let's get started and dive into the program. I made a couple of improvements to the original program. It actually had a couple of bugs in it and some code that wasn't used, so I cleaned it up. So let's take a look. At the top, as you'd expect, are the includes to bring in the library functions for both displays. We have macros that allow an easy conversion between milliseconds and minutes and seconds. We'll use these in a moment. We're telling the hero board that the 7-segment 4-digit display is connecting on pins 4 and 5. And then as before, we initialize the two displays. We're setting up an initial countdown for our liftoff of 70,000 milliseconds, which is 1 minute and 10 seconds. In the setup, we're setting up the 7-segment display to off, all zeros, and we're initializing the OLED panel. The loop has one of two cases in it. If we're currently running the countdown, we run the countdown function below. If we reach the end of the countdown and the digits hit 0, then it completes the countdown and displays on the OLED that we have reached liftoff and it is the end of the simulation. So in the countdown function, millis is a function that returns the number of milliseconds that the program has been running. So we simply deduct this from the time remaining and we set up the OLED panel to say countdown start. Then we need to display the countdown on the 7-segment display in minutes and seconds, which is where those two macros come in. And as you'd expect, we display the seconds on the second set of LEDs, and we display the minutes in the first two digits. And this value of true sets the colon to be displayed. Then we simply update the time remaining. Now, this is how we get the loop to stop. And this is where the original bug was in the program. And it didn't actually detect it reaching 0 properly. It wrapped around this time remaining field, which is an unsigned long. It wrapped it round from 0 to its maximum value. So I simply changed it to say that if time remaining is actually greater than the value we started with, 70,000 milliseconds, then the program has finished. In other words, we've wrapped around, we're done. And finally, there's the function that will render strings to the OLED panel. It simply takes in 2 strings. The second one is optional, and you can see that it displays the first string and then goes down 22 pixels, and if there is a second string, it renders that. So that's the program. So here are the 2 displays at the end of a run. Let's reset the board and watch it in action. So countdown start. You can see we're counting down from 1 minute 10 seconds. Coming into the last 15 seconds now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, liftoff. That's the end of the simulation. It's pretty cool to see both displays in action at once. Let's see what tomorrow's lesson will bring. So here's a complicated circuit. We have both displays like we did yesterday, except now we've got some extra components on the breadboard. And we've taken the 4-digit 7-segment display and now we're powering it off the breadboard. So the Hero board is powering the OLED display directly. And on the breadboard, we set up this positive and negative power rail, which is also powering the other display. It's also allowing us to use the buzzer. We've seen that before. And we've got the 3-switch block from previous days, and that's wired in with current limiting resistors into ground. So today we're going to be simulating the setup for the launch of our spacecraft back into orbit. This will begin a countdown just like we've done before, and during this countdown we need to activate 3 systems via the 3 switches. One is apparently powering our propulsion system. The other is providing power to our avionics. And the third is a proceed switch, enabling the liftoff sequence. After which time, we will receive an audible warning over the buzzer, and that will apparently give us time to strap into our seatbelts, ready for liftoff, which will happen when the counter reaches 0. Let's take a look at the program that's going to run this. Once again, I altered the code from the original, and you can see a copy of this code and that we modified yesterday in the description below the video, if you want to try my version out. So first we include the libraries. We have the same macros defined to help us with the minutes and seconds. Now we're defining some pins for the 3 switches, the buzzer, and the 7-segment display. We're initializing both our displays. Initially, we're going to set a countdown to 90 seconds. We basically have 90 seconds to initiate the 3 switch modes before liftoff. In setup, we do the usual housekeeping tasks. We define all 3 switches as input pins, and we display ready on the OLED display. In the loop, we have what is called a state machine. So we're going to read the 3 switches into variables propulsion, avionics, and proceed. And we also have a Boolean flag, go for launch, which initially is set to false. That won't be enabled until we flick switch 3, which is our proceed with launch. So in this state machine, if we are in that go for launch status, we display that on the OLED display and we activate the countdown. If just the first switch is flipped, we indicate on the OLED that we have armed the propulsion system. If propulsion and avionics are set, we display on the OLED that we have now enabled the avionics. And if all 3 switches are set, we are indicating we are ready for launch. It plays a warning tone on the buzzer and sets that go for launch flag. The countdown will now proceed. It's the same countdown routine we used before. And when the timeout reaches 0, it'll indicate that our spaceship is ready for liftoff. It'll display that on the OLED panel, and we are off on our way back to orbit. There's a short function for playing the tones on the buzzer, and there's the draw function we used before. Now this time I've wrapped it inside a display status function, which will do the OLED panel first page and next page for us. so we don't have to repeat that every time we want to display something. Let's see it in operation. So the OLED is telling us that the launch system is ready. There's no countdown on the 7-segment display yet. So first we're going to flick switch 1. And the OLED confirms that our propulsion system is armed. Switch 2. Now the avionics are set. And let's give the confirmation with switch 3 that we are ready for liftoff. Go for launch. The countdown starts. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, liftoff. Our spaceship should now be hurtling its way back into orbit, and we've escaped the planet. And as you're expecting right now, day 25 is a creative day. So just as before, please post in the comments below and let me know how your projects are going. In the meantime, stay tuned for the last video in this series, which will complete our look at the 30 Days Lost in Space Adventure Kit. And in that final video in this series, I'll be reviewing the entire kit, giving you my opinions. So stay tuned for that. Subscribe. Please like the video if you're enjoying it. And I look forward to seeing you next time. Cheerio.